Hello, everybody, and welcome to this, what should be a brief but hopefully informative tutorial on how to download, install, and utilize the Avogadro software that we will use for our first laboratory assignment. Um, I'm going to share my screen here to show the procedure. So hopefully at this point you would have created your table of physical properties. You would have gone through this procedure, found all the compounds that we're going to construct using the software. So we're going to actually build molecules, um, and created this table of physical properties, looked things up maybe on PubChem or other reputable websites, and also use this procedure to create your introduction and procedure portions for your pre-lab assignment. That will be due, or that was due rather, before completing this in-class assignment. So whether you are online or if you are in the hybrid course, completing this in the classroom, there's a couple slight differences. One, you will have to download this to your home computer if you are working online. But if you are in this course, in the hybrid version, then we provide laptops with the software already installed in the classroom. Or if you just want to download the software, please follow along. So what we see here is our procedure that was already utilized again for that pre-lab portion submitted on Blackboard. But for today, we're going to focus on this portion here, the equipment needed. So we see our Avogadro software is available for Windows. It's also available for Mac computers. So when we follow this link here, if we click this, it may not follow me. So I'm going to stop share and then go to where the website will lead you, where that link will lead you to this website here. So now we're in openchemistry.org/downloads, and we can see that depending on your platform, whether it's a Windows operating system or Mac, there's two different Avogadro download files here. So the .exe for Windows, the .dmg for Mac computers. So most students are able to successfully download, and then the installing software will prompt you, and it's kind of intuitive how to get through the installation process. But if you do have any issues with the download process, you can reach out to IT. You can find their information on RCSJ's website, or I can give you that information. They can walk you through while you're installing this, or you can reach out to me, send me some screenshots, let me know what's going on. But usually you can get through the download successfully, even if you get error messages. So I'm going to stop share here. So assuming that you were able to successfully get through that download installation process. Once you open the Avogadro software, this will be what the interface looks like here. So we have this kind of black screen here where we'll do our building. Over here on the left, we can see these windows are open over here. We have carbon selected, which is atomic number 6. So we'll keep that selected. One, organic chemistry is focused around carbon. So most of our compounds will, if not include carbon, but mainly contain carbon. The bond order is set to be automatic here, but we can change that to be double or triple bonds. But the automatic default will be a single bond. And then this click here for adjust hydrogens, that means that when I add my carbon atom, as we see here, just by clicking on the screen, not only do I add one carbon, but also 4 hydrogens. So the adjust hydrogens will fill the octet, fill your valence, so that carbon is satisfied here without adding any additional bonds. Notice that we have the draw tool on, that little pencil there. That's how that needs to be selected rather, so we can create these molecules. The navigation tool next door here, if I select that, I can now rotate my molecule. Throughout the procedure, you're actually asked to do this to create methane, which would be that single carbon atom surrounded by 4 hydrogens. Rotate, notice that it's a tetrahedral molecular geometry. Um, but say we want to extend this, say we want to make this into ethane. So I'm going to click on that carbon and I'm going to drag and extend that. Maybe I'll do propane. Maybe I'll add a third carbon. But notice that my bond angles, my bond lengths, they're not all equivalent. So in order to make this look more like we would see if we were to experimentally view propane some way, if we clicked on this tab here under the extensions file to optimize geometry, it will reconfigure this molecule so that we have equal bond lengths and the bond angles are appropriate now. So say we want to measure these bond lengths or bond angles. Somewhere in the procedure, it asks you to do that. So we'll go to our measure tool here. It has the little angstrom symbol with what appears to be a measurement being taken. So to measure a bond length, we need to click two atoms. So I'll click hydrogen to carbon, and it indicates that I have atoms 1 and 2. I'm not sure if you can see, but that distance down there at the bottom, that 1.094 angstroms, that's my bond length. Whoop. So I believe I'm still sharing that same screen here. So now if I want to measure a bond angle, I need a third atom. So the interior bond angle is at 110 approximate degrees. We know that tetrahedral molecular geometry, we tend to think of that at that 109.5 degree bond angle in a tetrahedral molecular geometry. So the carbon atom here is tetrahedral, so we expect the around 109.5. So again, we need two atoms to measure a length. Say I wanted to measure two subsequent lengths, I could click three atoms in a row. So now my first measurement would be between 1 and 2, and then the 1.519, that's going to be that between carbons 2 and number 3 there. So it's a slightly longer distance, which we would expect between two carbon atoms instead of a carbon and hydrogen. Um, so that's the measure tool. We see, say we wanted to go back to our draw tool here and change one of those hydrogens to be a substituent. In the procedure, it asks you to add some chlorine. So I can add, just by clicking one of those hydrogens, I can add two chlorine. So now I have 1,2-dichloropropane, etc. Right? So the procedure walks you through all the different molecules that it wants you to create. To save these molecules, we actually want to go up to File and Export as a graphic. If we export this as a molecule, we will only be able to open this in the Avogadro, but say I want to save this as my dichloropropane, I'll be able to open this file and then insert it into a Word document or upload it somehow to submit your post-lab assignment. So let me stop share here for a second. We're going to go back to the procedure just so you can follow along with what I was mentioning that had to be done here. So following along the procedure, after the introduction to this lab, we'll see, some nomenclature hints, some wedge and dash introduction as well. We can skip over building a molecule because that's what I just walked you through. The slightly different appearance is what you would see if you had a Mac computer versus my PC version. So we'll go through, I noted all these details, how to measure bond lengths and bond angles. Here we go. So in the procedure, it tells you at certain points to rotate a structure. So that would be that navigation tool that you would have to select. Then we get to drawing representation. So this is not only in the Avogadro software where we're drawing or creating rather molecules, you're actually asked to hand draw on, paper with paper and pencil, and you can take a picture, upload that as part of your assignment. Please let me know if you need a hand, editing photos, inserting them into Word documents, things of that nature. But notice here in part or step 3, we're going to now make ethane and propane. So anytime it indicates make models, that means build them in Avogadro. And then if it just asks you to notice bond angles, of course, this will be after we optimize that geometry. You do not have to write anything or answer a question. But if they ask you to draw complete structural formulas and condensed structural formulas, stuff like that would need need to be answered as part of that question. And if you need advice on how to do that, if we jump all the way back up here to part of the introduction, you're going to see those different representations: complete structural, condensed structural, bond line, molecular. So please give me what it asks for. Notice the complete structural and condensed structural were asked for with our ethane and our propane compounds. Continuing along in the procedure, oh, sorry if I'm going a little fast here. We get down to step 4 here. Now we're going to make butane. We're going to draw structural condensed formulas for that and include the model made in Avogadro. We're going to use our navigate tool. We're going to rotate some bonds, twist around the molecule. Um, Notice that, this molecule is not still in 3D space. It's vibrating, it's moving, it's rotating. That brings us to some different physical properties that we might see if we compare isobutane to butane. And then if we get to our PubChem website here, we can actually see how different physical properties may present due to different intermolecular forces. And then we get to larger isomers here. We get to our pentane, neopentane, isopentane. We're going to draw the condensed structural formula, name each of these 3 isomers. There they are there. So just assign names to them, create those structures in Avogadro, and then look up the referenced properties here, such as molar mass, melting point, boiling point, and density. You should have already contained or had all that information contained in your table of physical properties prior to this. So that's just kind of rechecking and confirming that now you're seeing how the structure relates to these different properties. Now we're going to move to create some substituents in this part of the lab. So we have methane, chloromethane, dichloromethane. Answer some questions. So number 11 asks for an explanation. We're going to draw a 3D wedge and dash structure of this molecule. So again, it notes how to do that in the introduction. Let's see here. So now we have chloroethane in this question. We're going to create the isomers of C2H4Cl2, so dichloroethane, and compare them. We're going to see 2 isomers possible. And then we want to see here, now that we have dichloropropane or C3H6Cl2, we're going to see more isomers possible. So that's a hint. Please make all those isomers, name them as you're asked to. And then when you're asked to do these measurements, you just have to note one carbon-carbon, carbon-hydrogen, or carbon-chlorine bond length, and then give me, again, just singular CCH-CCCl bond angles. And then now we have our post-lab questions here. So these will also be answered and submitted with the procedural questions. So we have for your post-lab assignment, you're going to submit all the images of the molecules created in Avogadro. So that's where you click, you make your methane, you click and drag, now you have ethane. So all those images. Answer the questions from the procedure. So if they're about bond lengths, bond angles, are they all similar bonds? Any type of questions that were asked, please give an answer. That would include those sketches, those 3D representations where you draw a wedge and dash, and then any of those measurements that were mentioned. Also for the questions 15 and 16 on pages 15 and 16, so these questions here. They should also be included to earn the full 25 points for this portion of the lab. So please let me know if you have any questions. Feel free to stop, rewind to this video, or send me an email with a list of questions. All right, thanks guys, and have a great day.